I never have time to waste. So hello, everybody. So again, this is actually going to be called conics. Oops. Conics, or another word is called conics, conic sections. Sorry, one second. Conic sections. I'm getting a million emails from my other class, sorry. Conic sections. Why is it called conic sections? Well, there are 4 ways we can sort of cut through cones, like slice through them. If we slice them completely horizontally, we get what's called a circle. Big surprise. If we look top down on this, like look straight down on it, we will get a circle. If we cut through it on an angle, we get an ellipse, which would look something like a stretched circle, some version of that. Parabola, we've seen before. If we cut it on an angle, we end up getting something that looks like this, or we can look at it. We know what that looks like. We've seen that in the second unit, or x squared or y squared form. And then hyperbola is like 2 parabolas that are kind of on top. So that's why it's called conics. It's ways we can slice through cones to make new shapes. And if we look at a summary here, you know the different, oh my goodness, everyone's jumping in all at once. Hopefully you can't hear that too loud. Circle, ellipse, parabola, or hyperbola, and they all come from a cone. So conic sections is the name. And today we're going to start with the, maybe not the most basic, but one of the more basic types, which is the parabola. So actually, we're not going to get to circle today. I tried that this morning in my other class, didn't work so well. We'll get through parabola, and then tomorrow we'll do the circle and the ellipse. So I'm assuming none of you had any time to watch Tom's videos. I still will give examples, but I'll try to explain the topic as good as I can. So first of all, there's a little interactive thing here if you want to check it out yourself. I won't look at it right now. A parabola is just a curve, and it's a curve that looks like it opens up, down, left, or right. Okay, and we've seen that before. And this parabola, which again is just a conic section, it's what happens if we cut through a cone in a certain way, has 3 pieces of important information that if we find them, we can fully sketch it or understand it. And these 3 things are the focus, the directrix, and the vertex. So if we look at this, well, let me draw my own sketch. For example, let's just say we had a parabola that looks like this, okay? That's a nice parabola. We would call that x squared form. Actually, I'm going to write it up top here. We would have a parabola like this. The vertex for that, maybe you already know, is the kind of minimum point or the base of the curve. So the vertex is like the base. If you were to drop a ball, it would kind of stop at the bottom. That's our vertex. Our focus, that might be a new idea for you, the focus. The focus is inside the curve, okay? It's inside the parabola. If it was on its side, it would be in the same place inside. And the reason it's called the focus, and you don't need to worry too much about this, is that if you were to, shine light rays, it would hit the curve and it would bounce into the focus or the focal point every single time. So if you were to shine a light in there, it would go right to the focus. So that's what this is used for in like real life, but we're not going to get too much into that now because that's a little bit more complicated. But that's why it's called the focus. It's inside the curve. And then on the other side of the vertex, we have something called the directrix. And the directrix is just a line that tells us, kind of how far away the focus is. I'm not going to get it actually affects how stretched out the function is. But these are the basic ideas. And finally, we can see we have focus, directrix, and vertex all labeled on this. The distance from the vertex to the focus is called this p. It's like a p value. And it's the same distance from the vertex to the directrix. Let me write in, this is the directrix. That's the directrix. Same distance from both of these. I'm going to scooch this over a little bit just because I have a few more things to write down today. That's our basic parabola. Now there are 4 ways that we can write a parabola, or 4 forms of a parabola. There's x squared form, So we can say x squared form, which is the one we're most familiar with. It would look like this. The difference is sometimes we have two ways that an x squared form could look, if you remember. It can be the smiley face or the sad face. So there's two ways we could write x squared form. I'm just trying to give you everything in one place here. That's why I'm writing this at the top. We have two ways we can do x squared form, smiley face or sad face. The upward or opens up is this positive p. I'll talk about what p is in a second. If we have a negative p, it opens down. Okay? I said I'll talk about what p is. Well, the reason I'm talking about p, I'll come right back up to this, is we have two equations here. We have this style equation, and we have this style equation. I'll come back to that in a minute, but you can notice there's a p in here. That's what we're going to be looking at. It's kind of like our a value for functions before. So that's our two ways here. Again, our vertex would be right here. Our focus would be inside the curve like this. Our directrix would be equally spaced apart on the other side. And we would call this distance p. You know, that's our distance p. I won't write that every time because it kind of makes the diagram a little bit ugly, but you get the idea. The other two types are y squared form. Okay, y squared form. If we have positive p in this case, it opens to the right. So y squared form, like this. I'll draw my important pieces in and then I'll explain it a little bit more. Okay, so x squared form opens like this, upward and downward. Kind of like when we have an x-axis of symmetry, we deal with y stuff. Y squared form, instead of being on the positive y-axis or on the y-axis, it's on the x-axis. So you can imagine instead of being like a smiley face like this, I'm trying to think of the best way to do this. Instead of being a curve like this, we turn to the positive x-axis instead, and it's like this. That's the only difference. Positive y, negative y, positive x, negative x. Hopefully that makes some sense to you. And then finally, I haven't written the last one, but you get the idea. I'll sketch it. Let me see. This way, must have a negative p, opens left. That would be also y squared form. And we have our vertex at the tip there. We have our focus inside, and we have our directrix outside. The directrix is actually an equation. So I'll write that there. We'll see what it means later. It's an equation. It's either y equals something or x equals something. But I've got my basics written down now. Focus, directrix, vertex. Three pieces for a parabola. Everything else comes from that. So let's look at the equations. It says here, general equations of parabolas with vertex at hk. So our equations, if they're written in this form, we can steal the vertex point or the coordinates from, I'm getting a million messages here. It's driving me crazy. Hopefully the Dropbox didn't explode. Okay. We can steal the vertex from the point. So here, for example, if we were to take these points, we would know that the vertex is h and k. How do we know that? Because I steal the x value from the one next to x, and I steal the k value from the one next to y, because it's x and y values. Same idea for the x squared form. I'll just jot a few things. P is positive, opens to the right. P is negative, opens to the left. P is positive, opens up. P is negative, opens down. We'll see a lot of that today, but I hope that as this goes on, you'll be able to make more and more connections. Let's see if there's anything else I'm missing. I think this is fine. I'm getting texts and calls nonstop because students are freaking out. So just give me 2 seconds. I just got to see if there's some emergency going on. Always possible. I got students calling me and all sorts of stuff. Okay, let's do an example so that this becomes clear. because honestly, this is not difficult, but there's a lot of different pieces to put together. So let's do this together. Practice 1. For a parabola, find the coordinates of the focus of the vertex and the equation of the directrix for each parabola and sketch the parabola. I'm always going to sketch it. So I'm going to go ahead and do C. First things first, I want you to look at this equation and tell me what form it's in. Well, the first thing, I'll do this for you the first time. The first thing I see is that I have this. I have a y and a square, okay? This y and square tells me that it's in y squared form. And if it's in y squared form, it means it opens to the right or to the left. Let's look and see if we can find anything else. Well, I can see that this is a 4 here, the positive 4. That means it opens in the positive direction that way. That's to the right. Okay, so we've used our y squared to tell us the form. We know it's opening to the right. I can actually already make a sketch. It'll look like this. I know my focus is going to be inside, and I know my directrix will be on the other side. I don't know where exactly yet, but I know that that's the basic idea. So we have 3 pieces we need to get in this order: vertex, focus, directrix. First things first, vertex. Let me make this a little bit better. Vertex. How do we get the vertex? We look at the values that are touching x and y in the equation. So I know that it's -1 and 2. How do I know that it's -1 and 2? Because I'm looking at this. I'm seeing it's x plus 1, so I just change the sign, make it -1. It comes right here. This one, y minus 2. The y value must have to do with -2. Well, it actually just changed the sign. It becomes +2. If you're not sure, you want another way to confirm that, just set it equal to 0. Here, x plus 1 equals 0. What does that give us? Really, it's x plus 1 equals 0. Solve it. It gives x equals -1. That is your value for the vertex. And the same thing works for y. Okay, so that's my vertex. I can right away, I can actually make a sketch based on just that alone. Left 2, up, left 1, up 2. That'll be my vertex. I already know it opens right, so I can even sketch that. I can say, hey, it opens to the right. And honestly, that already looks pretty good. It doesn't have a focus on the directrix yet, though. So the first thing I'm going to do is get that vertex. I got that. The thing I need to do is I need to work out what my p value is. What's the p here, which tells me where the focus and directrix are? Okay, that's easy enough. We know that this value here is 4p, okay? 4p equals 4. How do I know that? I know that this here, that's my 4p, okay? That's 4p. If you're confused as to where that formula comes from, remember I'm in y squared form, so I'll write this out just once. 4p x minus h squared. So instead of just thinking about it generally, I can say, hey, the thing in front of, the thing in front of that linear term, the thing in front of that x, the one that's not squared, that must be my 4p. That constant in front of those brackets is my 4p. So it equals 4 in this case. I solve it. P must equal 1. You can just divide it by 4 every time, honestly. Take that number you see here, in this case 4, divide it by 4, you get your p-value. Now the p-value is just like a middle step. We use it to find the focus and the directrix. Let me show you how you can do this without even thinking about it too much right now. I already have my vertex on the graph. I know my focus is inside the parabola, and I know that p here is a distance of 1. It's the distance from the vertex to the focus. It's also the distance from the vertex to directrix. And you can kind of ignore it if it's minus here. It's positive in this case, but we could ignore it if it's minus. It's just a 1. What does that mean? I can move 1 unit to the right, move over by 1, and that is my focus. So I can steal that from the graph. I can clearly see that that's 0 and 2. So the focus here is 0 and 2. Done. The directrix is on the other side of the vertex. So I'll just go back by 1. Again, it's just the distance of P, 1, and draw the directrix. The directrix is an equation, not a point. The directrix, that's a line where all of the x values are exactly the same. All of the x values are 2. So we say x equals, sorry, -2. All the x values are -2. This is our function. The directrix is an equation or a function, okay? And it just draws that line. Why is it x equals -2, you might ask? Because at this point, the value of x is 2, -2, -2, -2, -2, -2, -2, all the way around. All of those x values are -2 for that line. So we just call it the function x equals -2. One last way you can think about that is if you want to remember, is it y equals something or x equals something? It's x equals something because it's the one that the p value is next to. That's just a way to remember it. It doesn't actually have a relation to it really, but if you're confused about which one the letter for the directrix is, it's the one touching the p value. So I know I'm talking at you a lot, but for the first time through, these things take a lot of thinking, okay? So it's 11 now. Is there something I can review for this question, or would you like me just to do another example?
Another example.
Okay. So I'll do the exact same steps and it'll become more and more and more and more and more clear until it finally clicks, okay? The big picture. Tell me what form it is. Tell me if it opens left or right, up or down. Vertex. Once you have the vertex, you can get the p value after that to give you the focus and the directrix. So I'll follow those same steps. First things first. What form is this in? I'm looking at D now. I'm looking at this D. I'm just going to zoom in on it. I can see here that it is X. Oh, good job, Ahmed. So yeah, it's in
Square.
form, which means it's either going up or down. But in this case, I can see the p-value is negative, so it's opening down. That's open, yeah, open down. So I like to make a little sketch here because it reminds me what I'm trying to go for. I know that my vertex is here. I know that my focus is going to be here, and the directrix is the same distance, but on the other side. And by the way, if I look back at my previous example, I made a little sketch over here. You can see that even though it wasn't accurate, it is the same as what I got in the end. So at least I knew where I was going with this. Okay, so what I notice here is that in my final step here, I'm going to have to use the p-value to affect the y values because it's the p is where what tells you where to put the focus. Okay, but we'll get to that. So first things first, I know it's x squared for an opening down. Let's get the vertex. And let me keep my colors consistent here. So vertex, oops, sorry. Vertex, steal it from the x and y. Here, x plus 1, so make it -1. This is -4, so make it +4. -1 and 4. Good job, Abdul. So that's my vertex. Next thing I'm going to do is get the p-value. This is my first step. P-value is only a middle step. I know that 4p equals -4 in this case. Just divide this by 4. That's -1. You can ignore the positive. You can ignore the positive. Really, it's just the plus that we care about because it's a distance from the vertex. So before I do anything else, I should probably start my sketch because a lot of this can be done just by the sketch. So -1 and 4. 1, 2, 3, 4. That'll be my vertex. I know it opens down, so I can just make a sketch of that. I know my focus is inside, and I know that it's inside. It moves down by 1. So I'll go down by 1, and I'll make a focus right there. Okay, so I've already written my vertex. Now I've written my focus. And in fact, I can write my focus directly from that graph because the graph has helped me. What's the value? It must be -1 and 3. I see a question coming in there. I'll see it in a second. Okay, so Ahmed, you said P is always 1 or -1. No, just by chance here. It can be completely different. It could be a million. We'll get to that, okay? So in this case, the focus is -1 and 3. Third step, what's the last step? Directrix. The directrix is on the other side of the vertex. You just go up by P instead of down by P. And so that must be at 1, 2, 3, 4, 5, up. The directrix looks like this. And you should use a ruler for this. I'm just trying to do it quickly. All right, you can use a ruler for that. You should use a ruler for that. And that line is actually y equals 5. So the directrix is y equals 5. Y always 5. Now, yes, in this case, all the y values are always 5. And so the directrix is the line y equals 5. And if you're not sure which one to use, remember I said there's a little trick. You want to know if it's y or x here, if you're not so confident with this. Look at the one that's touching P, and you'll see that it's y. And it's just a little trick to remind you which one to use. And we're done. Let's make sure that we've got everything we need. I said we're going to check the form and see if it goes up or down. So we did that. Get the vertex, get the p-value, use the p-value to give you the focus of the directrix. And I did all those things. So I'm done. I've got everything. We can see that my final sketch matches my little. And Abdul, you said you mean in here. Yeah. So I'm done. So any questions on that? I'm going to try E, but anything I can clarify before we try E? They're all basically the same.
Mister, we put the vertex, it's -1 and 4. The minus one, it's come from x plus 1, and the 4 it's come from y negative 4. Okay.
Yeah. Yeah, and you can take the y plus 1, set it equal to 0. It's just a way of telling us what the vertex value is.
Mm-hmm.
Yep. Right, any other questions? That was good.
No, sir.
So let's try the next one. We'll move on to, can you repeat how I got the focus? Yes, I can. So the focus, let's try to be clear here. First of all, if you have the vertex and you know the shape, for example, let's just say we only had the, 1 second. So let's say right now, I was at this stage. I don't know what the focus is. Let's go ahead and look at this. We know where the vertex is, and we know that the focus is inside the parabola, yeah? It's where light would focus in on if it bounced off the walls. So you have the focus in here somewhere. You know it's down. It doesn't shift left and right. It must shift down. I solved for P here already. P is 1. So that means it's just down from the vertex by 1. So our vertex right now is -1 and 4. If we go down by 1, it must be -1, 3. So our focus, you'll notice I said, okay, go down by 1. Now I have my focus. And I went ahead and just labeled that. It's -1 and 3. The directrix, same idea. Go up from vertex by 1, and I have my directrix, okay? Is that
Okay, Mister, why you say it's 4p equal -4? From where it's come 4p?
Okay, so we have a general equation. In this case, the general equation matches this shape. That was messing up. Okay, this is our general equation, our general form. You'll notice that if we had our standard form here, whatever's in front of this linear part is 4. So that's just whatever that number is, we call it 4p. So in this case, we know it's a 4, or sorry, we know it's -4. So in this case, we had 4p must equal -4. That's our number.
Okay.
Okay, I'll keep that there actually. Any other questions? These are all good questions. I'll try another one. So if you want me to go back, obviously let me know, but these recordings are all. So let's see, E. First things first, I would make you do this on your own, but I'd rather just work it through with you. If you rather just tune me out for a minute and try it yourself, just do that. But some of you, I know they need the extra support. I know I would probably when I first started this. So right away, I see that this is y squared form. That means that it's going to be sideways. It's either this way or that way. I see that I have a -8 here. That means that P is negative, and so it opens to the left. Those are my two things that I started with. I'll make a sketch. It looks like this. That means that my focus is inside here and my directrix will be on the other side of it. I'll do the exact same thing I did before. What's the vertex? So the vertex, notice, careful, -5 is our y value. So that's an easy one to mess up. 2 and -5. Notice that this is our x value, this is our y. X here is on the right side. So we still need to go over, we kind of need to go over to that side of the equation and grab the x value. So they're not always in the order that you expect. Okay, but as long as you get that, it should be okay. So notice this comes from over here. This one comes from over there. I don't mean to mess up the equation too much, but yeah. Focus at 1 and -5. Well, let's see. I'm going to go ahead and get the p value. P value in this case, sorry, 4p must be equal to -8. Or you can just take the -8 and divide it by 4. The -2, or just 2. 2 is the distance from the vertex. So I'm going to start making my sketch. I know that the vertex, let's see, 1, 2, 1, 2, 3, 4, 5. The vertex is here, and it opens to the right. So I don't know if I've given myself enough space here. It'll open up like this. And let's see, the focus must be inside of that, and it must be over by 2. So I'll sketch that out. 1, 2. Focus must be right here. That's our focus. Focus then is, let's see, 4 and -5. So Ahmed,
Sir, why it's the problem is on the right? So not on the left?
my fault.
No problem.
These are easy to get backwards. I mean, I can get it right the first time and it's easy peasy, but as soon as something goes wrong, it all messes up, right? So sorry about that if you're drawing what I drew. It's probably a big pain. Okay, so that's my parabola. The vertex is still 2 and 5. Let me just make that the right color here. Focus will be 2 over. So yeah, it's not going to be 4. It's actually going to be 0. I go over by 2 to get my focus. So that would be 0, -5. My focus. And this is my vertex. And finally, the directrix is on the other side of that. So it goes over by 2 and it looks like this. The directrix is a line. It is not a point. So what is it? Is it a line where all the y values are the same? No, there's different y values as you go down this, but they have the same x value. So it's x equals 4. So really, this is my important pieces here. Directrix, focus, vertex. You don't need to write all these numbers in. I'm writing those numbers in to help you. And I might as well label this. This is x equals 4. Okay, you can see that they all follow the same steps. How is the directrix for, Ahmed? I know that my vertex is at 2, -5. I'll erase this in a second, but my vertex is at 2 and -5. I know that the directrix is 2 over from that because P here is 2. So just shift over by 2 in the same direction as the focus. Any other questions on that? Before we move into the other style? We don't have a lot of time to do a million more examples. So Tom did a lot of examples on this. I just did 3 extra examples. And once you do them, you'll realize you follow the exact same steps every time, the exact same steps. So for those of you that like things that kind of follow a recipe, this is going to be a really good topic for you. In fact, a really good unit for you, because it's all this kind of thing. You just need to understand what your pieces mean, and then you'll be okay. So the rest will be homework. Let me know if you need to review a piece of it here or there. So now we're going to graph them. We just sketched them. Now we're going to graph them, just a little bit more information. We're still going to get our vertex, our focus, and our direction. But this time we're going to just graph a couple extra points. Tom did the examples A and B. So you can go watch the video to see those. But I'll try a different example here. Let me show you how these are actually quite simple. First of all, I can see this is x squared form. And I can see that this is a positive 4. So it should look like this. It opens up. You have a focus there. You should have a directrix on the other side. X squared form opens up. Hopefully you're clear on that now. What's our vertex? Well, our vertex, there are no numbers subtracted or added to x or y here. So it must be 0, 0. That's a nice easy one. Yeah, Abdul, you got that? Excellent. So I'll just write that on the graph right away. I can write down what the 4p is. I know 4p here is 4, so divide it out. This means p is 1. So I can even write the focus and directrix already. I know that it's going to open upward. So I know that I'll do the focus and directrix after, actually. Let me get a few more points. But I know it's going to look something like this, yeah? Something like that. My vertex I'll put in here. And now, I know I need to go left and right, and then it's going to be up there somewhere, but you know, where exactly? So I need to check a few points. I need to put a point to the right of this, and I need to put a point to the left of this. So you can choose any point. I'm just going to choose to go over 0, 0, 0, 1. Yes, exactly, it is 1. I'm going to choose to go over by 4 and left by 4. I'm going to go over 4 values that way and 4 values this way. You'll notice it's symmetric, so whatever you go one way, just go the other way. I'll just add 4 and I'll subtract 4 here. If I substitute this into the equation, what do I get back for y? Well, 4 squared is 16 divided by 4 gives me 4. So this gives this, based on the equation, we're going for y here. And -4, because of symmetry, it's going to be exactly the same. Yeah, Ahmed, you got that. So we know that this graph, once again, is going to be something like this. So it's perfectly symmetrical. We don't need to do this twice. If you go left and right by the same amount, they'll always be the same. So let's graph those. Let's see, we have -4 and 4. I think that's right here. 1, 2, 3, 4, 1, 2, 3, 4, yeah. And then the other one on the other side. So now we have the shape. You can just, do your best. If you don't have these notes printed, that's okay. Just use a notebook, use graph paper, something like that. But you do need to at least be able to make a basic sketch. You can get graph paper at Carrefour or something like that. And now we have our points. We still need to put in our focus and directrix, but that's the easy part. The focus, we just go up by 1. So Abdul already had that. And the directrix, we already know we go down from the vertex by 1. So the directrix is going to be, it's not a point, Directrix is going to be the line y equals -1. Remember, it's a line that all the y values are exactly the same number. -1, -1, -1, -1, -1 is the y value for all of these. Or look at the number that's next, look at the variable that's next to the p, and that's the number that you take. And that's it. We have our vertex. I should probably write that just to make it clear. That's our vertex there. We have our focus a little bit above it. We have our directrix, y equals -1 below it. And then we have a couple points that we plotted just to get the width, just to see how wide it is. I knew the best points to put in for this, 4 and -4. I knew they were going to work out well. You might not. So just go like 4 or 5 on either side. Even if you get a decimal, it's not a big deal. Just put a point in and solve for y. See what you get. Okay, any questions on that?
Yes, Mr.
Hmm.
Why now we get back 1 and the last question we get 2 in the direct?
You're talking about directrix? What are you talking about this?
Yes. Yes.
It's just depending on what letter, what number is in front of the term. So here we have a 4, yeah?
Yeah.
Before. That, based on our equation, is 4p. So 4p is our standard. It's always 4p, and then we say equals to whatever that number is. Or in other words, take this value and divide it by 4.
Mm.
Always divide it by 4.
Mm.
So in the previous example, it was an 8, yeah? So we took 8 divided by 4, gave us 2.
Yes.
In this
Negative.
question, it's a 4, so just divide it by 4, we get a 1. The negative and positive doesn't really matter because y is just a distance.
Mm.
If it's negative, okay, whatever. Negative means it opens down, positive means it opens up.
Oh, okay.
It just means we go that far away from the vertex.
Okay.
Any other questions from anyone? Going once. Going twice.
No, sir.
Oh. Again, I wish that Zoom had piece of cake. Good. I wish that Zoom had a typing option. You know, every other chat function has it. Every other chat program has it. I don't know why this doesn't. Let's do one that's a little harder, but I still don't think they're difficult. Once this stuff clicks, once you know what a vertex, a focus, and a directrix is, once you understand what P means, this stuff all falls into place. So right away, just looking at this graph, I know that it does this. And you should get to the point where you can do that just by looking at it. How I knew was because I saw it was in y-squared form, and I saw that it has this negative. Y-squared form is left and right stuff, and then it opens to the left. My vertex, I'll write this out. And yeah, go ahead in the chat. I see you're writing things out. Excellent. Just go ahead and try it yourself if you want. The vertex in this case is -3 and 2. It's my vertex. I stole it straight from the things that are touching x and y here. So -3 and 2 looks like this. But again, if you don't have the notes, just use graph paper to make these sketches. I'm going to make -3 and 2 here. That's my vertex. Now, let's get p because the p value is easy. I can divide -12 by 4 or make it more specific. 4p is -12 here. If you're not sure why, it's right here. That means p is -3, but really we just care about 3. Okay, so we'll go left or right by 3. In this case, the focus will be 1, 2, 3 over here. And it's opening to the left. That's my focus. This is my vertex. I can already draw my directrix if I want. It's 3 back the other way. And I already know the equation for that. It's going to be x equals 0 because of the way that it's set up. So I already know these coordinates. Focus is going to be, I can read it, 1, 2, 3, 4, 5, 6. It must be -6. And 2, which Abdo I see that you have. Excellent. directrix is going to be x equals 0. And I saw that straight from the graph. Or you can take, wait. Yeah, it's your vertex is at -3, so you add 3. We're adding 3 because of the p-value here. It goes back to 0, x equals 0. The sketch really is the key. If you have the sketch, everything else comes together. Now, I'm not allowed to graph this yet because I don't have any way of knowing how big it is. You know, I know it's going to look something like this, but you know, is it that big? Is it this big? Is it this big? Like those are totally different graphs. How can you solve it without a sketch? What do you mean, Abdo? How can you solve which part without a sketch? The way that you would do it, and I'll write just to the side. How would you get the directrix without a sketch? Directrix? Well, let me show you something. You have your vertex, yeah? In this case, -3 and 2. Your focus on the directrix, because this is sideways, we know that it's opening its y-squared form. You're going to be affecting your x values. So really, it's -3 plus or minus your p, plus or minus your p-value. And based on the, you should always sketch it. Let me just start there. But based on a mental image of this, you should know that one of them pulls it to the left, one of them pulls it to the right. In this case, if we say -3 minus our p, we would get our focus. If we have -3 plus our p on the, get it to the right side, we would get our directrix. That's the big idea. And this works in any case, honestly. So if you wanted to make it general, you would say h plus or minus p, comma k. For this form. In the other form, it would be plus or minus k. But I don't like to teach it that way because most students get confused. Okay, so let's fill in our table of values. Ahead of time, I did this ahead of time. I know what nice x values I would choose and y values because I don't want to get fractions. But basically, we need to go and put a point up here somewhere and put a point down here somewhere so that we can see how big this is. So I'm going to tell you which points to use. I'm going to try 8. I'm going to go 1, 2, 3, 4, 5, wait, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to try a point up there, and I'm going to go 7 down the other way. 4, 5, 6, 7. So that'll be 1, 2, 3, 4, 5, 6, -6. I'm just checking, I'm putting in 2 y values here, but you can put in any 2 values, it makes no difference. And see what the x values get. So if I take these, put them in for y, it'll give me back an x value, okay? So I'll just sketch that here. I'll put in 8. You'll only have to do this once because it's symmetrical. 8 minus 2, square it, equals -12 x plus 3. I'm just solving for that x. So this is 8 minus 2, which is 6. Square it, I get 36. This is -12x minus 36. And so I would have 12x equals -72, which means that x equals 72 divided by 12, 6. And so the other one's also 6. Now, that's a little bit of work, I get that, but it's not difficult. The idea is that you choose any y value or x value. You can choose anything. Just put them in there. They just need to be on either side of the vertex and work on it that way. Did you say y equals -6? -6, yes, sorry. Thank you for that. I'm glad that you caught that. And you can solve for y instead of x. Yeah, it's better that you solve for x though, because you don't need to worry about squares. And sorry, I made a mistake here. This is supposed to be a 4. My mistake. I'm trying not to get too off track here. I want you to stay focused on what the important pieces are. The important pieces are the vertex, the focus, and the directrix. The table of values is just a way of putting in a few points to see how wide this is. If you put in random points, you can still work it out. You'll just get decimals or fractions. It makes no difference. Just do your best to put a point. But in this case, we've got our points now. So -6 and 8. Again, I made a mistake with this one. Make a note of that. -6 and 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like I have a point here. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now I have a point there. And you'll notice it's symmetrical. So you only need to do that work once. You just kind of work it out logically for the rest. And we're finally finished. And you get something like this. Again, doesn't need to be perfect, but you should at least have a function that looks very similar to mine. It's not this tiny little function. It's not this giant stretched out function either. It's this function. Okay. Most of the marks for these, I'm going to focus on vertex, focus, and directrix, and then use the table values just to help you out. Okay, any questions on that? Yes. Yeah, you can put this into Desmos if you want. I'll show you actually. So there's no reason why. Because we have that assignment today, I'm going through this a little quicker than I normally would. I'm not showing as much cool stuff on Desmos, but I'll bring up Desmos just to show you can do it. So I'll graph this, and then you can steal that if you want. I probably should have mentioned that, so I'm glad you brought it up. Square it equals -12 x plus 3. And look, we got this. The problem is it doesn't tell us where our focus and directrix are. So you have to get that yourself. But it'll at least give you the vertex, -3 and 2. And we can see that if that is the case and we have P, we could probably steal another value from this. For example, you could probably say, hey, this is a nice point. And this is a nice point. So you could say -6 and 8. -6 and -4. Hey, big surprise. That's exactly what we got. The problem is you still, like I said, would need to add in your own focus and your own directrix. But at least it would get you part of the way there. So thanks for that. I'm glad you brought that up. So, like I said, the nice thing about this unit is you kind of follow a recipe. And once you can do one, if you can do one with full confidence, you can do all of them of that type. So I'm not going to do any more of these. These other ones can be homework. If you want some advice on which points to take, I can give you that. But honestly, any points will work. Just do your best and it'll work out. I'm sure it'll work out fine. So the last type, what have we done so far? We use the equation to make a little sketch or to find the important points, the vertex, focus, directrix. Just then we use the vertex, focus, and directrix to make a graph. And now we're going to find the equation. And finding the equation, honestly, if you understand this stuff, is not difficult. There's 3 steps, which you don't have written in your notes. I've written them here for you. First step, determine the form. Is it x squared or y squared form? And it'll look like this, yeah? The only difference is one has an x with the square and one has a y with the square, but we already saw those. Second step, determine the vertex and the p-value. Nothing new. And then the third step, write the equation. The equation, you don't need the focus and the directrix to write the equation, but sometimes we'll see we're given the focus and directrix, and we use that to find the equation. Is it always quadratic? Yes, parabolas, by definition, they are squared. That is what they are. And so it will always be a quadratic form. Yeah. For parabolas. Now, by the end of this unit, we're doing circles, ellipses, and hyperbolas. Some of them are squared, some of them are linear, but there's no cubics. Yeah, only linear and quadratic. That's the only things we're worrying about. So let me skip through the examples because Tom did those. In fact, if you were to just watch that video on that, you'd get all of this. But let's work through this. So write the equation. We need to write the equation, and the sketch is key. Thankfully, it already gave us a sketch. Let's pull everything we can from it. First things first, we have the vertex. I'm sorry to talk so much, but this is something I need to talk through for you to understand. The vertex here is -1 and 1. I took that directly from the graph. So I'm just looking at my notes. Oh, before I did the vertex, I should have noticed the form. This is x squared form. Hopefully you can notice that because it's either a sad face or a happy face. It's not sideways. So x squared form, and it opens down. So what we're going to get, we should get a negative p-value. Our p, if we solve for it, it needs to be negative. If it's not negative already, we need to make it negative. So look at this. You can see the distance between the vertex and the focus is p. That's by definition the p, and still the vertex to the directrix also p. So we can steal that directly from the graph. In this case, our p-value is -1. So Abdo, you got that. -1. It's important that we write the negative this time because even though it's just a distance, we need to use it to make our formula. And that's actually all we need. X squared form, remember it looks like this. I'll write this down here actually. The equation, it's going to look like this. X plus or minus something squared, because it's x squared form. It's going to be 4p plus or minus 4p. Y plus or minus something. So we just need to fill this in. Well, let's see what we have. We have x. We know that this is -1. So we're going to say +1. It's the opposite idea. Square it, we've got that side finished. Negative plus or minus 4p, well, 4 times this, 4 times our p is 4. So it's going to be -4. We don't need p, of course, we replaced it. If you're not sure what I'm talking about, it's plus or minus 4 times -1, which is 4, really. 4 is the important thing. We know it's negative, so we make it negative. And then what's in the brackets here? Y plus or minus something. We know that vertex gave us a 1, so we change it to -1. So it still follows a recipe. We still follow the same logic, but you do need to understand what all these things are. If you don't know what a vertex is, you can't do it. If you don't understand the focus, then you can't get P, right? So be careful with this. But this was our first step, second step, third step. Hopefully that's clear. I'll do one more of these, maybe 2 more. I know we only have 3 minutes left. So I'll just do one more quickly and then I'll open the Dropbox, okay? So first, write the equation for a parabola. I'm looking at this one. Write the equation for the parabola with a focus at 4, -4, and a directrix at y equals -2. So our focus is at 4, -4, 1, 2, 3, 4, 1, 2, 3, 4. That's our focus. Directrix is at y -2. Looks like this. That means our parabola must be partway in between. So based on this, I know my vertex must be, and I'll let you think about this a little later, a little more, that must be at -3 because it's partway in between the focus and the directrix. The only other thing I need is my p-value. My p-value here must be 1. And it opens down, so it must be -1. Again, I'm doing this quickly, but I want to make sure you have as much time as possible for your assignment. And that's all we need to write the equation. We know it's x squared form, so I'll just write it out and you can think about it more later. This is x minus 4 squared equals -4 y plus 3. Where did all this come from? The vertex gave us the x value for the vertex there. Our vertex gave us this y value. And finally, our p value, which we got from the graph, this is p, gave us this information. And remember, this is 4p. Okay, so there's more stuff written out. Sorry, there's more examples done online. Tom did a whole bunch of them. Now you've seen more from me. That's the entirety of the parabolas topic. So most of this now is just for you to do practice, and you must do the practice. We won't do it in class, but take your time to do the practice, okay? So I'll end the video here, and then I'll explain the assignment. So thanks everybody for watching.